Hi, good morning everyone. I am Gabriela Sant'Agata, a chemist and a researcher of the Institute for Polymers, Composites and Biomaterials of the National Council Research in Italy. The main research topics investigated at my institute can be synthesized as the correlation between the structure, properties, and potential application of polymer-based materials. In particular, the group of research I work with is engaged on the synthesis and chemical-physical characterizations of biodegradable polymer-based systems to be used in agriculture, food packaging, and biomedical areas. In addition, we are engaged with the recovery of biomasses coming from wastes of agri-food industries as novel sources of upgraded materials, such as biopolymers and bioactive compounds that can be used for several applications. In this presentation, I will show you just an example of exploitation of alternative feedstock biomass used as novel bioresource to produce upgraded material in a frame of the circular economy approach. So the first question is, how is it possible? This interesting and amazing approach, the circular economy approach, comes from the concept of sustainable development, firstly introduced by the Nobel Prize Brundtland in 1987. She asserted that sustainable development must satisfy the needs of the current generations without compromising the ones of the future generations. So, another question is how to reach the eco-sustainable approach, how to reach a sustainable approach. Following the indication of Brundtland, there are three key points to consider. The first one is that the rate of consumption of natural resources must not exceed their regeneration ability. The second one is that the amount of wastes introduced in the environment must not exceed the ability of the environment to dispose them. And the third one is that the amount of petroleum non-renewable substances should be constant with the time. So, translated to the environmental concern, the above definition is correlated to a zero-waste industrial production with positive reduction of carbon footprint and CO2 emission. So, how to reach this challenging result? The main and focal approach is moving from the linear model of economy based on take, make, use and dispose to the circular approach based on take, make, use, reuse and regenerate resources, thus allowing also a worthy regenerative economic system. Thus, the transition to a circular economy is the currently measured objective for European Union industrial policy strategy. So, in order to foster the so-called circular bioeconomy, the attention of the academic world is increasingly turned towards the exploitation of biomass coming from the waste stream. What is biomass? Biomass is a material coming from plants and animals, so it has a biological origin. A significant fraction of biomass are industrial byproducts, wastes coming from agri-food industries, agricultural wastes, cellulose-based residues of paper production. All these dairy-produced scraps are used as novel sources of upgraded material. As an example of recovery and application of agri-food waste following the holistic approach, we used citrus byproducts to extract pectin fibers and polyphenols. Actually, a typical citrus waste is made of semi-solid residue composed by simple sugars like sucrose, polysaccharides like pectin, fibers, protein, lipids, organic acids, essential oils, vitamins, and polyphenols. So, can you imagine what pity could it be to dispose in the environment of citrus byproducts without a previous treatment able to extract these important and renewable sources? For this reason, following our expertise, we recovered the pectin, polyphenols, and fibers from the citrus byproducts. Pectin is a biopolymer widely used in food as a gel-forming agent, able to preserve food from organoleptic and quality deterioration due to the oxidation process. It is also used as an emulsioning agent and for the solidification of jams, for example. But it is also used in biomedical application like a hemostatic agent and a drug carrier. Also, polyphenols and fibers are extracted and can be recovered and were extracted from citrus byproducts. In order to perform and produce a biocomposite, i.e. polymer-based systems composed at least of two or more distinct components or phases, which combined together can provide an upgraded material with improved performance with respect to the individual constituent materials. In particular, pectin green extraction from citrus waste was performed by using a water solution of acetic acid, since acetic acid is admitted in the agronomic practices of biological agriculture. A semi-solid suspension was obtained that after centrifugation and separations provided two fractions, a liquid one containing pectin and a solid one containing the fibers and polyphenols inside. After the pectin recovery, a film was obtained through casting method and water evaporation. The solid residue, mostly represented by fibers, was dried, ground, and recombined in different amount, 15, 25, and 35%, with pectin solutions for the preparation of the biocomposites. These biocomposites were used as biodegradable mulching films sprayed directly on the soil, as shown in the figure, in substitution of petroleum-based films, which are highly pollutant for the environment, since mulching films are not biodegradable, are dirty of soils, fertilizers, hormones for plants, and everything is useful for the growing of the cultural plants. And so after the using time, these films are left on the soil or at the edge of the streets, and most often they are burned with the high impact for the environment. On the obtained biocomposites, mechanical puncture tests were performed. These tests in general could simulate what occurs on the soil when a plant starts to grow and puncture the soil. The results evidenced that the pectin-based biocomposites, including 35% of fibers, were much more resistant than pectin film to the rupture, due to the presence of the fibers, which improved the texture, and due to the presence of bioactive molecules like polyphenols, which acted as a plasticizer, i.e. Small molecules able to interpose between the macromolecular chains, increase the distance, and favors the macromolecular chain mobility. Thus, under stress, the chains can resist to rupture. So, to sum up, in this presentation, citrus fruits byproducts was used as biomass of pectin. Pectin was extracted from citrus pomace waste by green method. Following to the extraction, pectin was recombined with residual fibrous fraction to obtain biocomposites, to be used for spray mulching activity, in this way following a whole holistic approach framed in a circular economy strategy. Before concluding my presentation, I would like to thank our dear friend, colleague, and scientific mentor, Dr. Mario Malinconico, whose memory is always alive in our art. Before me, Mario was responsible for CNR of the Bioplastic Europe project, and so much he started doing for it. We really hope to follow his eminent guidelines. Of course, I thank all of you for the kind attention, and goodbye.